Okay, the last thing we discussed in the section 9.4 for mathematical induction, it really is kind of like swapping gears. We were talking about the sum of the first n powers. This is really kind of a transition. This is a skill you're going to need. Really, when you get into calculus, this is a skill that we use quite a bit in Cal 2 when we start talking about integrals, and we talk about the area under curves and such as that. When we start talking about the definition of integrals, we use these quite a bit. I need you to add these rules right here to the bottom portion of your yellow formula sheet. So if you could pause this video and then copy these down on that sheet of paper, that would be great. You are allowed to have these, and you're going to be in a mess if you don't. So please put these on your yellow piece of paper. You should have, there's 5 rules. There's a rule for when you have a constant. That's the reason you have, this is when you have a 1. And then when you have I to the first power, when you have I squared, when you have I to the third, and I to the fourth. Now, the book I copied these out of used I's. Quite honestly, the homework paper that I'm copying uses N's. So don't let the variable mess you up. I'll show you how this works here in just a second. So if you will pause this video, copy these down, then we'll be ready to work. Okay, so, now what we're going to do is we're going to use those formulas to work some of these problems. Basically, they're shortcuts for our different summations. The instructions say find the sum using the formulas for the sums of powers of integers. So some of the very simplistic problems look like this. Let me get a brighter color here. You have n equals 1 to 30, and then it just has n, where, like I mentioned to you a while ago, they're not using I, they're using n. It doesn't matter what the variable is here. They could use Q, R, M, L, P. Nobody cares, just whatever variable is there, roll with it. Okay? So it doesn't matter if it's I, just use your formula. Okay, the point is, look at the exponent. This is n to the first. So you want your rule for I to the first. And your rule that is I to the first was, that was the rule that said n plus 1 all over 2. That's what you were looking for. Okay, so you want, this is your n value. Okay, so everywhere you have n in your formula, you're going to put 30. So we have 30, and then we're going to have 30 plus 1, which is 31, and then you're going to put it over 2. So grab your calculator and work this out. And quite honestly, that would be 15, right? So 15 times 31, oops, let me get out of this. 15 times 31 is 465. There we go. Now, there's some neat little tricks that you can do with these. You can do, like if I ask you for 6 I squared, well, what you can do with that is that means, say, 6 times like, let's see here, excuse me, they're not gonna, I kind of skipped a step on you. Let's do it this way. Let's do this. If I did 6 I squared, but we're doing the sum of when n is 1 to 10. Okay. What that is 6, and then you're going to copy down this part. So basically what you're doing, your coefficient can be pulled up front, okay? And then you're going to, you apply your summation to your variable here. And you're going to get your formula that you need. You just hang on to your coefficient. Now, let's do the formula that you need with I squared. Well, I squared is n plus 1, and then 2n plus 1 all over 6. Okay, we'll just keep this 6 out front, okay? Now, your n was 10. So come in here, and everywhere you see an n, put 10. Well, 10 plus 1 is 11. 2 times 10 is 20, plus 1 is 21. Okay, now, quite honestly, this 6 and this 6 cancel each other, so I've got 10 times 11 times 21. So 23, 10. Now, the only other thing that you might want to see is a problem that said something like, okay, let's do the sum, and let's go from 1 to, I don't know, 7. And let's do 8n squared minus 5n plus 4. And we're doing all of that. Well, what that means is, see this little summation, it's like you can distribute it. So you're going to have 8, and then you're going to have your little summation of n squared. And then you're going to have negative 5, and then once again you're going to have your summation of n. And then you're going to have 4, and then you're going to have a little summation of 1. So remember, it has to be 1 because that's a constant. There's no variable here with 4. So you've got to break it down to where these things match all your little rules that you copied down. So now you're going to have 8 times whatever your rule is, negative 5 times whatever your rule is, and 4 times whatever your rule is. So for n squared, we had n plus 1, 2n plus 1 all over 6. For n, we have n plus 1 all over 2, and for 1, we had just a regular old n. Now, according to our problem, 7 was n. So, we've got a 6 on the bottom. This would be 7. This would be 8. 2 times 7 is 14, plus 1 is 15. Okay? So my 2 stays down here. 7 goes here. 7 plus 1 is 8. And then that's going to be 7, right? Okay, we need space. And a calculator. Well, I thought I bumped this thing down. There we go. Okay. It's all about typing it in at this point. So I have 8 times 7 times 8 times 15. And then I'm going to divide that by 6. So 1120 minus 5 times 7 times 8. All divided by 2 is 140 plus 28. So I can go back and just type this in. And my answer comes out 1008. And that's about as detailed as we're going to get with the powers of sums right now. But if you can get a handle on that, that sure will help a lot once you get to calculus and you start talking about integrals. So good luck, play with those, have fun.